Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
They are among the biggest explosions of radio energy in the entire universe. They generate more energy than 1 billion suns.
A quote from Brian Cox. "It could be shocking. It would shine like a second sun because it's only 600 light-years away, and it could be tomorrow." The red supergiant Betelgeuse could be about to explode. Images show that Betelgeuse is completely dimmed and very unstable. Researchers around the world are eagerly awaiting this unique event. At a distance of just 600 light-years, we on Earth will be able to see the spectacle with our naked eyes. When Betelgeuse explodes, it will shine brighter than the entire galaxy for a few moments, and even weeks later, we will still be able to see the remains of the supernova. What exactly will happen when Betelgeuse explodes? As astrophysicist Brian Cox announces, we will see a light so dazzlingly bright for a few moments that it will look like a second sun. During the day, we might be blinded for a few moments and see a very bright flash. If the star explodes at night, it will be as bright as day for a few moments. Betelgeuse is about to explode, that much is certain. But on a cosmic scale, shortly, could be 100,000 years or even just one day. The crazy thing is that Betelgeuse could already have exploded since the light from the supernova will travel through space for 600 years before it reaches us. We will only see the extreme brightness 600 years after the actual explosion. This idea shows the extreme dimensions of the universe in an impressive way. It will be exciting for us as soon as the supernova becomes visible, and we are already following every little change on the star. In 2019 and 2020, the red supergiant Betelgeuse experienced a dramatic decrease in brightness, which subsequently became known as the Great Dimming Event. This sudden drop in brightness led to speculation that the star was about to explode. Other experts were certain that the star would become brighter shortly before the final event. Researchers eventually found that the dimming was caused by a huge ejection of dust that blocked some of the star's light. It is likely that the old, gasping star Betelgeuse experienced something like a mass ejection. In these events, which we also know from our Sun, a star ejects large quantities of material into the surrounding area. Betelgeuse is 1,000 times larger than our Sun, and the amount of material was much higher. The dimming was caused, on one hand, by the dust cloud, and on the other hand, the star had experienced cooling at the site of the material loss. In March 2024, the American Association of Variable Star Observers reported that Betelgeuse had again experienced a dip in brightness of about 0.5 magnitudes. Researchers anxiously and excitedly observed the dimming since late January. This dimming was also a sign that we are not familiar with Betelgeuse. Any change that is unusual can be an indication of the explosion. Again, the scientific community researched intensively and eventually found that the extreme dimming was a direct after effect of the Great Dimming Event of 2019 and 2020. Now, we have brand new studies and simulations from astronomers at the Max Planck Institute for Astrophysics showing that the turbulent surface activity of Betelgeuse could also lead to optical illusions. So, what is the real status of the red supergiant, and will we see the explosion soon? The theory of the binary star in Betelgeuse, while it has been proven that Betelgeuse is well on its way to going supernova, remains a mystery as to what stage the red supergiant really is in. At the moment, Betelgeuse is not a normal red supergiant. It behaves very differently from other stars of this type observed in space, and there could be an as yet unknown reason for this. Some of the star's characteristics do not fit the picture, and so researchers came up with a fascinating theory. Betelgeuse could be the result of two smaller stars merging. In this case, we would not see one old star on its way to going supernova, but two. The star rotates so quickly and contains more heavy elements, such as nitrogen in its atmosphere, than is the case with typical red supergiants. In a simulation carried out by astronomers, it was shown that Betelgeuse could originally have been a binary system consisting of two stars. One of these stars would have attracted the mass of the other, ultimately leading to a merger. This process would have disrupted the internal material of the newly formed star and pushed the heavy elements into the upper layers, which would explain the unusually high concentration of nitrogen. The merger would also have accelerated the rotation of the star. Normally, red supergiants rotate much more slowly. However, the simulation plausibly showed that the additional transfer of angular momentum can be explained by the merger of two stars. However, a counter-study also showed that the fast rotation of the star could be a misinterpretation. The activities on the surface of the star can lead to optical illusions that only look like an increasing rotation. Betelgeuse's actual state is therefore very difficult to assess. The only scientific certainty at present is the activity of violent, deep convective currents that are constantly pushing billions of tons of material to the surface of the star and making the core increasingly unstable. Betelgeuse is also definitely in a late stage of its development. Scientists suspect that the star is currently undergoing the carbon-burning phase, which typically lasts about 1,000 years. When this phase ends, Betelgeuse could explode within decades rather than millennia, as originally thought. The renewed dimming of Betelgeuse in 2024 and the continuous fluctuations in brightness could be the first signs that the star is approaching its end. Betelgeuse has a special significance for us. Betelgeuse is not just any star, it's one of the brightest stars in the constellation Orion, and this has always had a special meaning for humans. Ever since our species has looked up at the sky, this star has been particularly huge, red, and conspicuous. Betelgeuse probably bloated into a red giant more than 100,000 years ago, so we don't know it any differently. But it's only recently that we have become aware of its peculiarity and its fate. The earliest records of Betelgeuse come from ancient Egypt and Mesopotamia, where the star was particularly revered as one of the brightest in the night sky. In the Middle Ages, Betelgeuse was mentioned by astronomers such as Ptolemy in his star catalogues. He described the star in the 2nd century as conspicuous and reddish, and he wondered what this meant. The systematic scientific study of Betelgeuse began in the 16th and 17th centuries when telescopes became much better. Galileo Galilei, one of the pioneers of modern astronomy, observed Betelgeuse and studied brightness fluctuations in detail. Even then, much more powerful telescopes made more detailed observations possible from the 18th and 19th centuries onward. William Herschel, one of the most important astronomers of the time, classified Betelgeuse as a variable star that changes its brightness over time. The decisive breakthrough in our understanding of Betelgeuse came in the 20th century with the development of spectroscopy. In the early 1900s, astronomers were able to analyze the chemical composition and temperature of distant stars for the first time. The spectroscopic study of Betelgeuse showed that the star was a red supergiant in the late stages of its evolution. Edwin Hubble, known for discovering the expansion of the universe, also contributed to the study of Betelgeuse. In the 1920s, Edwin Hubble used the newly developed techniques of astrophotography to study the size and structure of the star. In the 1950s and 60s, the invention of the radio telescope ushered in a new era. This technology made it possible to observe Betelgeuse in different wavelength ranges, which in turn provided completely different insights into its physical properties and the star's atmosphere. Finally, in the 1990s, the Hubble Space Telescope revolutionized Betelgeuse's surface observations, and we witnessed the irregular brightness fluctuations for the first time. Since then, researchers have divided the fluctuations into several almost regular cycles. Since the beginning of the 21st century, we have had the next great technological innovation, interferometry. This allows astronomers to make extremely precise measurements of the surface of stars. Observations with the Very Large Telescope in Chile have shown us exciting images of irregular surface activity and huge convection cells for the first time. So, we have only known the details around Betelgeuse for a relatively short time, which is what makes it so difficult to make an accurate prediction. The most recent observations in 2024 showed another significant dimming, supporting the theory that Betelgeuse is heading for a supernova explosion. Modern technologies, such as high-resolution spectroscopy and computer-aided simulations, now allow us to precisely track the exact state and future evolution of Betelgeuse. While Betelgeuse remains an object of intense scientific study, The chronology of its exploration demonstrates the progress of astronomy and humanity's growing ability to unravel the mysteries of the universe. What do we really know about supernovae? Our science sometimes seems so self-assured, and it's easy to get the impression that the researchers of this world are in possession of real truths. But especially when it comes to the universe, many theories and opinions are still based on pure speculation. We know the true nature of supernovae just as little as we can really examine Betelgeuse precisely. Certainly, people of many eras have witnessed huge explosions of dying stars, but they have usually been misjudged. The first documented observation of a supernova dates back to 185 AD, when Chinese astronomers observed a guest star in the constellation Centaurus. The bright visitor was visible in the sky for several months and then disappeared again. In 2006, the brightest supernova of all time was observed by astronomers worldwide. Records from China, Japan, and the Middle East show that the supernova, now known as SN 1054, was so bright that it cast shadows at night and was clearly visible during the day. This star may have been about as bright as researchers expect Betelgeuse to be. Another famous historical supernova occurred in 1054, when Chinese and Arab astronomers observed a new source of light in the constellation Taurus. This supernova left behind the colorful Crab Nebula, which is often depicted today. In 1572, the Danish astronomer Tycho Brahe saw a supernova in the constellation Cassiopeia. Brahe's detailed records of the supernova SN 1572 were somewhat more advanced because he was one of the first to recognize that the sky is not unchanging, as Aristotle had claimed, but that it's subject to dynamic changes. Kepler then introduced the concept of the supernova in 1604. Kepler noted a stella nova in his astronomical diaries and assumed that he had witnessed the birth of a star. Kepler's supernova was the last in the visible range of the Milky Way that could be observed with the naked eye. Basically, we have only known what supernovae really are since the introduction of spectroscopy in the 19th century. Dying stars, subscribe to the channel now. The best videos are coming.